I'm Shyam DWARAKNATH. I'm a research scientist at LBL, and I just wanted to do a very quick, I wouldn't even say this is a pitch for the materials project, but things to think about in the development of Optimad. And as a typical scientific project, there's a small core infrastructure team and a very large PI team. So lots of managers and a few ants doing the work. So the way we think about Optimad and really any infrastructure projects is what are the different pillars of development or design that we need to focus on. And in materials project, we start off with the data. We have data API or data pipelines. We have the core API, which is really kind of where Optimad would sit, but that has to be developed in the context of what the website is. So this could be Evgeny's kind of client cores-based Skyscanner type of website, or even what the deployment looks like. So where is it going to live? How is it going to interface with data? How is it going to interface with other APIs? And in the materials project, we have a huge variety of data. So our challenges are slightly different than I would say many other groups. We focus on variety. So we have stability, we have elastic properties, magnetic properties. We're doing a magnetic topology, for instance. We have phonon band structures. We've recently added X-ray absorption spectra, so we're looking at characterization methodologies. And so the materials design ecosystem is actually very large in the context of what we have to do. So as Optimad grows, that development of new data paradigms or the properties in which they're encompassing is really a critical concept that needs to be very flexible so that as new databases come in, they can enhance whatever is the current API with a new concept, and that can grow back into the Optimad design. The other side of that is the deployment. And I highlight this because the materials project, I think we've had probably some of the most success in terms of hitting a large user base. What we normally talk about is the number of registered users, which at this point, somewhere on the order of 130,000 registered users, and we pretty much have users from across the world. What that means is that our deployment usage is pretty variable, but it's also very large. So this is just a snapshot from today from our Cloudflare account, which gives you an idea of the last month's usage of the materials project. So about 120,000 users. You can see a very large spike that contributed to a total request quantity of about 125 million requests. We average about 1 million requests per day. That's on normal days, but we do tend to see spikes like this, and about 2 terabytes of data served. Some of it can be cached, but not much. So this is kind of the, if Optimad is super successful and ODBX and Aflow and everyone else gets the same kind of data usage that we do, these are the challenges you're going to have to face in terms of scaling, in terms of meeting the deployment necessities that could potentially hit your databases. So Optimad has to be developed with this in context, that there is a large user base. It's not just our groups here, and they're very hungry for data. And this is not even the ML community at large, right? So if we talk about machine learning in general, and the user base going outside of what we'd consider the machine learning for material science community, this could grow very rapidly. So with all that in context, I'm kind of glad that kind of some of the questions that came around Marcus's implementation, I think it was Evgeny that mentioned this, which is that we need to have a language that is interfaceable with users. And you really have to think about the ways in which you lose users. It's not about gaining users, because the only way you gain them is if they find you. And then after that, every little impediment is a means of losing users. So first they have to find you. Then if they can't access you properly, so that could be page load times, that could be the user language. For us in MP, we're very Python heavy. So we're really about our PyMatGen toolkit. And so not being trained in Python is an issue. So how do you translate that into web infrastructure? And then not being able to understand the data. This is something I think is kind of implicit in Optimad, but we focus so much on the query language and the API and not really the structure of the data in terms of its inherent understanding. So making that as clear as possible is also another critical feature in terms of the development of Optimad. Obviously, this is a nascent technology. I don't know of many other scientific domains that have come together to build a single API. And so we've done a pretty good job up to now. But as we continue to grow, these are all things that I think are important in all of our minds as Optimad develops. And I say this because this all ends up being infrastructure changes. And so the reason I highlighted the fact that we have 3 core infrastructure people at the beginning and lots of PIs is that in the end, it's going to be a small group of people implementing the changes. And in the end, it's going to be their interpretation of a lot of these problems that's going to then create what ends up being Optimad. It is a group consensus, but you can see on the Python tools and even the Optomat GitHub, that there's a small set of people who are the loudest and therefore are making a lot of the decisions. So it's important that other people who are invested in the development and success of the Optomat API are as vocal about what they think is important, even though they may not be the person developing the API or developing the Python tools or developing the client. And the real issue is that infrastructure needs to change. Infrastructure changes are painful. They take a long time, and Optomat effectively represents an infrastructure change. So we need to have a long-term mindset important. So whatever ends up being the changes or the things that we end up talking about in this workshop, I hope everyone has this idea of what do they want Optomat to look like in, say, 5 years, and try to work back from that. How successful is it going to be? What is it going to enable? What kind of people are going to use it? How is it going to interface with the material science challenges of 5 years from today? And how is it going to solve some of the material science challenges of today? Obviously, the technicalities that we've kind of talked about over and over again, we want modern standards for API. I think that's a good thing. I think we shouldn't get too plugged into the modern standards, mostly because, or we shouldn't get too derailed by the standards, because modern standards are changing on a regular basis. Our API changes every single day because the Open API specification is changing faster than we can evolve. So it's really about trying to adopt those standards in a most effective manner and not being focused on trying to stay up to date with whatever's the latest and greatest. And actually, at the end of the day, I think the GitHub is probably the thing that's the most important. The fact that we are doing this as a community, that it's open, use the flows of GitHub. So pull requests, even if they're not done, even if they don't actually end up being pushed into Optomat, having that openly developed, that community development concept is really critical, I feel, for the success of the Optomat API specification. And as long as we continue that ethos, I think no matter what ends up happening in this workshop and the next, say, 4 to 5 workshops, we're going to have a successful implementation of Optomat. I think with that, I will end my little pitch.